But glad you all are here. We're going to have a little discussion in regards to backflow prevention and what it curtails to as far as type of installations, different types that I've encountered across the country. And I'm here on behalf of ABPA and San Antonio Water System. So glad you took time to set in. Part of the rules and regulations that we deal with in the state of Texas is a group called the Texas Commission on Environmental Quality. TCEQ really kind of came into play in the early 90s and started setting up rules and regulations for backflow prevention. For the particular states that you guys may be in, they may be either tied to the health department, or they may be a standalone entity, or they may even tie back to the plumbing side of the house. In Texas, it's actually two separate entities. Anything that deals with irrigation or water district or water purveyor is all under TCEQ. Anything that deals with the plumbing and gas industry is over under the State Board of Plumbing Examiners. So part of what we deal with is some of the rules and regulations. How many of you that are dictated under different types of plumbing code, either under IPC or UPC, correct? Okay. Any other code district out there that you deal with? Okay. The IPC, or International Plumbing Code, UPC, Uniform Plumbing Code, those are the two primary that are now across the country. And a lot of the irrigation side of the house gets looked at by your plumbing inspectors on a local jurisdiction. In San Antonio, of course, the irrigation services that we have there, irrigation, landscape, recycle, reclaim. How many of you deal with any type of reclaim system in your area? Okay. Very specialized, very technical, and we'll get into that a little bit as we go through the presentation. How about rain harvesting? How many of you have rain harvesting? Okay. If you may or may not be aware of it, some of the rain harvesting across the country is not allowed. It actually becomes waters of the state. So depending on the state that you're from, you may not be able to collect rainwater. So if you're moving from one locale that you can use it, you may walk into another one where you can't. So it isn't the fact of when it hits the ground, it's the fact that when it hits anything within the parameters of the state, it becomes part of the state's water system. And then, of course, temporary water service, again, we're back to the purveyor. Backflow prevention for irrigation hazards, the way we look at it is once you put an irrigation system on site, it's truly indigenous to that site. It doesn't go any place but that site. That being the case, we look at backflow prevention in different aspects of it. The first one you look at is internal isolation, specific to the hazard that it creates. So you have to kind of open your mind to what could possibly be in an irrigation system. Well, you guys are in the industry, so don't know how much you've really delved into it, but over a period of time where an irrigation system either sets dormant or even if it's an active system, can carry all types of things in it. We've discovered biofilms, we've discovered fecal coliform, we found fecal matter, just pretty much anything that you would find on a yard, a backyard, you're going to find in an irrigation system. Fertilizers, all kinds of good stuff. So in that perspective, we like to isolate the irrigation system to itself. On internal containment, that's where the water purveyor looks at that option of what's the best to protect the water distribution system. So you have to take a lot of factors into play, and that's where we have what we call an internal containment, and then the last one would be a containment that's located out by the meter. From the irrigation landscape aspects of it, there's only really two types you deal with. There's residential and commercial. Now this is on a residential application. The piping that you see going in and out, what's kind of unusual about this is if you're common to distribution line off an irrigation system, what they actually did is fed into the house, then that goes into a water softener, and then comes right back out and goes over to an external hose bit, okay? What's wrong with that picture? Your domestic's water directly tied to the irrigation system. The guy that discovered this, man, he was, all these years working in cross-connection control, had never found a cross-connection. He goes out, turns off the number 2 shutoff on the backflow preventer, kills the water to the house. The people that had lived there years before and had the house built, the guy was an attorney, and his wife was sick all the time. Couldn't figure out why. So what's that tell you? Anyway, they discovered it, repiped it, life's good. If you're familiar with backflow prevention assemblies, this is a pressure type vacuum breaker. This is designed where it has a critical line right here, and that critical line is supposed to be 12 inches above the highest head on a particular irrigation system. As you can see, they weren't real keen on installation, or nor did they pay any attention to manufactured literature. So, bit of a problem here. They did go in and recorrect this after the plumbing inspector went and discovered it. And if you got any questions as we go along, please throw your hand up. Be glad to answer those. This is a kind of a combination residential office type setting. If you will, your meter boxes are located out here in the front. They are separate services going in. And as I say, it's kind of a residential and commercial application, since they can work out of the house, so to speak. And what we discovered was what was going on behind the scenes. So that's what we found. As you can see, they did have the wherewithal to put a backflow prevention device in, and it was going into an air gap that fed where their pump was, and then all of these pipes that go into the system here and then back out to the distribution system. Now, what was unusual about that application is the fact that they had an 18,000 gallon bladder tank that was right out in this area, and that's the way that they were going to do all their watering. So what we had to do is go back and require backflow prevention protection out here at the meter box itself. We weren't in a position to allow internal to occur. But they had no clue what kind of little monster that they would build, or had built. And nor could you see it. I mean, there was no indicators of anything like a harvesting system even in play. The only thing that gave my guy a heads up is he followed the downspout. And if you follow the downspout, it goes in the ground. It doesn't distribute out on the ground. So at that point, he asked the guy, hey, where's that water go? Oh, we got an 18,000 gallon storage tank below grade. Oh my gosh. So then that's when we discovered what was going on. This is a 10,000 square foot home. We got, everything's bigger in Texas, right? We got some bigger homes down there. So this particular one belonged to an insurance company. We actually did some presentations for these guys. So they asked us to come by and do a water use survey. As you can see, it's well landscaped, really pretty. Over here is where they got their incoming water service. So we went into the house, two-story house, 10,000 square foot undercover, had an elevator built in the back for the upper and lower floors. Anyway, when we went back where the swimming pool was located, we saw this big wall there. What's behind that wall? Well, that's what we discovered. He had all these harvesting tanks. And of those harvesting tanks, they collected all the rainwater. Whenever they decided to turn over the water in the pool, they would put the pool water back in here. And they used that for all their landscape. That's the reason why it was so lush around there when everybody else's yards were burning up. So we had to do a little education for those folks as well. He was very applicable to what we needed done, so he put in all the appropriate backflow prevention. Nice job. Nice job. Part of the residential of what we've discovered that can be problems, if you will, things that you need to do to promote your landscape growth and your grass growth, but it creates havoc for a water purveyor as far as trying to keep something isolated or staying on that particular site. So part of what we encounter is dealing with chemical additives. You'll have some that won't have anything but just straight water, and as I told you before, there are still things that collect within that irrigation system, so you need to be cognizant of it. The potable water auxiliary on site, where we just showed some of the harvesting tanks, and then the potential of a recycle reclaim service if the water provides it or if it's something that you're doing particular to your site. On the commercial side of the house, a lot of the similar scenarios. Again, same thing where you may have potable water or with recycle water coming into the site. Some of the commercial sites, and these are ones that we provide recycle water. We're kind of unique in San Antonio, had to think a little bit different, where instead of calling it reclaim, it's actually being recycled. So it comes in as black wastewater into a treatment plant, and if you go to the tailwaters of our plant, and hold up two glasses, you can't tell a dime's worth of difference between what's potable water and what's recycled. Only when you go in and start testing with chemical constituency with either your pH or your conductivity or TDS, only then can you start disseminating what type of water you actually have. So as you can see, we provided to the river. How many of you ever seen the San Antonio River or been to San Antonio? That river during certain times of the summer is nothing but recycled water. And the problems that we had with the recycled water is it made the water too clean. You can go down there at times of fiesta and all that kind of stuff and find chairs, tables, baby buggies, all kinds of stuff because the water's pristine. It's just crystal clear. And so we had a bit of a problem with that for a while. But then it kind of became notoriety, if you will. But a particular fish called a log perch, if you do any research on it, a log perch will not come in water that has any type of contaminant in it. And because of that, recycled water being added was the first time that a log perch had been discovered in San Antonio River waters in, I forget what they said, 20 some odd years, just because of the high pollutant level that was in it. Some of the parks have it there. Majority of the public golf courses have it. We do have it at universities, private courses, specialty organizations, and the only limited residential that we do in San Antonio is on those colleges. We really don't have it going out to residential customers. One is because the exorbitant amount of distribution that it would take and going back in pre-established residential customers is just virtually impossible. This particular connection, this is where they had the irrigation going in to a combination well. You can see the backflow preventer located underneath it. It was out at one of the local golf courses, and they didn't even realize that they had their domestic water directly connected again to their irrigation system. So they were a little bit perturbed about having to do a disconnect, but they did it pretty readily when the plumbing inspector wrote them a citation. And that's one thing that water purveyors normally don't have a citation process. We have to go to a more enforcing agent, if you will. So we've had a great working relationship with our plumbing inspectors. So for you that are trying to work on it on the enforcement side or conservation side, they are a great friend to have. They can go out there and make things like this happen for you, and we just don't have that type of authority. We can go out there and cut the water off, but then that makes everybody mad. You know, here you go in there, you do a specific isolation to a potential hazard that could hurt the people on the site, and it turns out to be a win-win. And once they realized the problem they were creating, they were very, appreciative of the actions that were taken. These are some that kind of scare you because you never know where that pipe's going. They'll call for what they call a temporary meter, and in most cases, if we know they have an air gap set up or something like that where they're doing watering out of tank trucks, so forth, but when they ask for a pressured connection, we always require a high hazard backflow preventer, an RP, reduced pressure principle backflow preventer, and just due to the fact we never know where that's going to end up, and you can see that just takes off for a while out there. Anyway, once they got out and discovered it, that's what they had tied up off of it was a bunch of watering tanks for cattle on site. Well, you think, well, that's not a big deal, right? As long as it's air gapped at the tank. But the way they normally do it is just like that. They'll take a hose, turn the water on, throw it off in there, and they may or may not have a hose bib vacuum breaker, i.e. the reason why we do something like that, because the last thing you want to be doing is drinking with the livestock. So, now this is a real nice apartment complex that they have there that they built in San Antonio. As you can see the water feature out front. What was interesting here is they had no backflow prevention protection on the water feature. And in most cases in San Antonio, if it's during the summertime under the conservation effort, that's not even allowed to run under ordinance unless it's recycled or reclaimed water. You can't continue to use potable water for it. So one of the latest crazes is they're actually going out to our treatment plant, picking up recycled water, capping their potable service that goes to these water features, and then they're putting that water in there because of the unbelievable evaporation rate. I mean, they'll lose anywhere from 1 inches up to 6 inches per day, just depending on the amount of heat or how many days it's run consecutively. And you can get recycled water for half the price of potable water. Again, another one of those unknowns. You can see they got the RP set upside down. So we have all kinds of fun chasing these. And in this particular end, this is on an on-site hydrant. So we didn't actually have control of it. Just happened one of my inspectors went by and saw it. Again, the unknown pipe taking off around the corner out there. And this is a concern. When you see that, you may have a guy like this. And this is down at a very prominent place in San Antonio now. It used to be an old brewery. Now it's actually a multi-tenant space, commercial, residential, restaurants, really a neat site. Anyway, he didn't want his picture taken because he was up there spraying some ortho up there to protect his weed base, or his weeds, that's what it looks like, but plant base and everything was going well. And he goes, I really don't want to be in the picture. I said, no, it's for something that we wanted to do a little presentation on. But the thing is when you go back to where the point of the hose is connected, as long as you got the appropriate protection there for your water purveyor, you got the appropriate protection there for the folks that are on the property, it's a non-issue. So he can go out there, do all his landscape watering, use chemicals if he needs to, and everybody's protected. It's a non-issue at that point. Sorry about the quality of the picture, but you'll just see that black hose laying there. On the same site, we followed over to where the meter box was located, and they went over to a quick coupler, and that's just a quick coupler set in a box. And then it goes off to a temporary sprinkling system. These are no different than dealing with the garden hose, like dropping off in the livestock tank. We have problems with those. So if you can imagine, currently we're somewhere around 700 square miles of infrastructure that we deal with every day, and we have somewhere around 700,000 water connections. And those are hard pipe connections. That's not even counting these temporary connections. So people kind of get a little lackadaisical, if you will, and if they find a place to stab in and get water, they just go for it. And a lot of times we don't even know about these until somebody drives by, or you may get a concerned citizen, something like that. But that's a lot of fire chasing that we do if you think about the magnitude of it every day. This is out at the one of the Air Force bases. Used to be Kelly Air Force Base. Now it's an open city base. The feed that you've got working here, that's air gap on the potable. That's recycled water going in, and it feeds over to a cooling tower. But they also pipe it out, and this goes back out and distributes to on-site irrigation as well. What's good about the reclaimed water is all the phosphates, the nitrates, things that are in it. Terrific for all your landscape and turf. It's a little tough sometimes on your woody plants. They don't really like it much. If you don't hit them down towards the base of the trees, it does cause some leaf tip burns, things of that nature. But they've started doing a lot of in-ground bubblers and doing different technology that has really improved that a lot. But it saves a golf course. We had one saved almost $25,000 just in fertilizers by using the reclaimed water. This was kind of interesting, new development out here. They put a sign up, very proactive, water use out here, non-potable water, alternative water. They were going to be pumping out of a lake. But they kind of got the cart before the horse, if you will. If you can see, they're actually hooked up to our fire hydrant. There's a fire hydrant meter. So they were saying alternative water, but no, they were tied directly into us at the time. But they had their heart in the right place. They just hadn't got there yet. This is out at one of the golf courses. There's a potable water connection coming in here, recycled water connection here. And again, it's a great resource for those landscape areas out there. It's worked really well. How many of you have ever seen the Alamo or heard about the Alamo? They put recycle down on the Alamo as well. You can see all the purple pipe. For those of you that have a little historian in you, what this is called is an acequia. And the acequia actually, in the olden days, delivered their water source. And part of the problems they had in San Antonio, I'll share a little history with you, is people kept getting sick, and they couldn't understand why. And the idea was it was supposed to be fairly decent water that was traveling through the acequia. Well, they found out that an anthropologist was studying Indian bones, and whenever he got done with them, he was dumping them in the river upstream. So that's where they started having problems with the sickness that went on for a period of time. But what they do with the acequia nowadays is they put those high-dollar Japanese koi in there, the real colorful fish, and they decided to put recycled water in there. Well, the algae bloom was so enriched, you couldn't even see the fish. It looked like the Loch Ness Monster moving around in there. So they ended up putting a potable water feed back in, and they air gapped it to dump into the acequia. It was just too enriched. For rain harvesting, any of you that have looked at the actual schematics of it, they're pretty simple. The design of this is actually on-site isolation, where he has no potable water from a purveyor, he has no well water, so he's got the ability to actually get his rainwater, come in, do a first flush, do a capture of the system, run it through, have a pressurized tank, do his filtering in ultraviolet, bring it back into the house, and he's virtually got pharmaceutical grade water. We've got one guy just north of town that he captures on site on an annual basis somewhere around 60,000 gallons of water. For him and his wife alone, that sustains them totally for a period of 2.5 years. So he's got it figured out right down to exactly gallons per day that they utilize. There's a picture of his concession of tanks that he has go in, and he's got where it does the first flush mechanism that goes off wherever his tanks get full to the top. The interesting thing is because the way these tanks are structured, he can go to any of those tanks, open the top, dip a cup in, get a drink of water, and it's perfectly safe. There's no organic matter in it. It's just inert. There's some of the parameters of what he has within that water. As you can see, compared of a typical parameters on a water system, then take a look at his on rainwater. You know, compared to 120, he's at 21. You come down to sulfates, we're at, the water purveyor is at 100, he's down at 0.1. So you can go right down through it and see as far as under total dissolved solids, they're absent. He don't even have any. So it's pretty amazing what they can create with just rainwater. And then, of course, the ones that are important to a water purveyor, if you can see it down at the bottom, is total coliform and E. coli, totally absent, not even present in the water. Some of the House and Senate bills that I've been working with some of these individuals on, where we're trying to get that worked out in the state of Texas, is pretty prohibitive at this point. They really don't like them to use it to capture specifically for their indoor water use. They have no problem with the outdoor, but they really struggle, legislators do, just because they don't understand using it in the house for drinking water. So we're working on that. They're trying to get a lobbyist on board, and they're going to try to reintroduce a bill to clean up some of these House bills and Senate bills that are currently out there that affect what they try to do day to day. The group out of Texas is known as the Rain Catchment Association. So if you want to Google those guys up or have an interest in getting into some of this, it's really big in Texas or some of the arid climates. This is a rain harvesting system that was set up, but it's also a central collection that's on the backside, and believe it or not, all of this that you see under roof is a house. They do have an attachment of a greenhouse. Greenhouse alone is better than any house I've ever lived in. I mean, it's just unbelievable. And they have a central collection system underneath. This is all concrete. They do a central collection, and then it goes back to those tanks that I showed you in the previous picture. This is groundwater influence, and of course here in Florida you guys have a lot of groundwater influence. So when you look at the aspects of where you're at, it can even happen in an arid climate. It does in San Antonio, where we have an average rainfall of around 18 inches a year on a good year. Of course, we've been in about a 3-year run of a drought now, but we have groundwater influence that comes in even on some of the golf courses. You see it just virtually coming up through the ground. Some of your new superintendents kind of freak out because they think they got leaks in their system when they're not familiar with the groundwater influence. But this is down by the Hemisphere Tower, and this is actually a holding tank, and then they utilize that. They had a I think their inbound was somewhere around 150, 200 gallons per hour is what they were getting as far as groundwater influence. Rainwater harvesting, showed you the on-site storage. Most of the systems they try to do are that are above ground. They try to do gravity feed. Some of them are pump systems. That's where the water purveyor gets a little bit concerned because of the potential that they could create back pressure or push water back into our distribution system. And then alternative makeup as far as utilization of gray water on site or rainwater. And then I don't know, how many of you have got involved in some of the color coding side of it? Have any of y'all dealt with any of that? That's a big concern because some of the plumbing industry is real into, if you will, putting purple pipe on site just because it's a irrigation system because they want people to be cognizant of it. Well, AWWA looks at that differently because once you apply purple pipe, then they're looking at it from the reclaim aspect of it or recycle water. Creates a lot of confusion, especially for you backflow testers because they don't know what they're getting on out there to test at that time. Is this being supplied by, a non-potable water or a potable water? So it does create a problem. Rules and regs that we have there, we have an IG as far as a guidance document available to them. There's a regulatory guidance, information guidance, but what about the commercial businesses? They're still trying to address that. I sit on a work group for the state of Texas, and we're working on some of those rules and regulations now to try to get those more applicable to what the different water catchment folks or reclaim folks are trying to look for. So House bills are, have been passed, showed you those a few minutes ago, but we're trying to rework those, flesh those out a little bit. That's a typical gray water setup. If you haven't ever seen one, that's where they've went in and plumbed it throughout like a two-story house. Get down to your bottom level here, and then you've got your washing machine off of it, and then you've got where part of it will go back to the sewer system. Some will be held in a black tank or gray water tank and then reused for either your toilets or urinals, things of nature like that. As far as gray water is concerned, washing machine water, bathroom sink, shower, condensate. Kitchen sink, can't use that, and the reason being is you have a grinder pump in there, the potential of food byproduct getting in there. So they're not real up on that being used. But dual piping in the homes, if you do it when a new home's going up, pretty affordable. You try to go in and do it after the fact, it can be pretty impactful as far as your overall project. Again, this is a picture of some of the groundwater influence that we have there in San Antonio. This is on the south side of town. Again, another base that was converted to a city base, and it has just an exorbitant amount of groundwater influence that comes in. They have since developed all this, and they have to go through a sieve test. It has to meet certain criteria that when you have groundwater influence before you can go out and put an alternative water back in the same locale. In this particular end, the engineering firm was able to convince the state that during times of plenty and the blending of waters, it would truly be a non-issue by putting recycled water in there. So they were allowed to do that with the fact of still having groundwater influence. This is on a reclaim system again, groundwater influence. Have you ever heard of AT&T? This is one of their main buildings that they have in San Antonio. They have groundwater coming in at such a huge rate that, believe it or not, people do flush toilets during the day, and it was costing them exorbitantly in potable water. They had a engineer come in, take a look at the way their system was set up, and they were able to get into the walls, repipe everything where they could utilize reclaim water and took the potable water off of it. By doing that, now all their urinals and toilets are actually flushed with groundwater influence. So it saved them an exorbitant amount of money every year. So well worth their time and effort to get that put in. During times of heavy rain is where you get the groundwater influence, where it recharges. If you have aquifers someplace that it will actually have the ability to store underground water, it can become artesian, as I told you a minute ago. You can actually see it springing, if you will, coming up out of the ground. And the only way that you can know the difference between that is just no different what I was telling you about recycle or reclaimed water. In that particular end, you have those constituencies where you have TDS, conductivity with those, or with a chlorine test kit. That way you can tell exactly what type of water that you have out there. So a lot of times they'll just go out and do a strip test on that, tell them pretty quick whether it's groundwater influence or if we've had a main break or whatever type of water it happens to be. The color coding, again, I made a note about that, and AWWA is concerned. See, AWWA originally came up with the fact of using purple pipe for your distribution system that's out in what they call the utility corridor. Nobody ever thought any further than that, other than the fact that if you tie it into a purple water system, you're again going to tie into a purple water system on site. Well, with the rain catchment, groundwater influence, all those guys were looked at as a non-potable water source as well, so they didn't want to create a hybrid because it costs more money. Whenever they develop purple pipe, it's by putting a certain pigment in there that gets that color parameter. So it's very cost prohibitive if you try to go to any other type of color. So the offshoot of that is where they're going in now with either bagging or tape or something like that, where they actually put that on the pipe to give you a differentiation of what happens to be in the ground. Part of the thought was, especially on the irrigation side of the industry, is why not put in green? Well, how many of you know what the designation is for green nationally? Sewer. So nobody wanted to identify it as sewer, so they had to try to come up with something. So we've talked about it as being exotic as, you know, purple with black spots, or, you know, do something different, but it truly very cost prohibitive to do that. So I think it's just going to be a educational thing. We'll just have to continue through that and try to get them better educated when they do some type of on-site improvement. Temporary connections. When you get into temporary connections, they can be very difficult for a water purveyor, but a great resource for irrigation folks. You can come in, get right next to where one of your control valves are. You've got a connection for whatever size that you need to make your connection to, and it works terrifically. The problems for the water purveyor is if we don't have appropriate backflow prevention and you put a pump on it or create a back pressure or back siphonage effect, then all of a sudden we're having to deal with that. I'll give you a scenario that happened in San Antonio. If it happened today, it would cost somebody immensely. But back then, it was in 1978, we had a huge insurance company. Any of you ever heard of USAA? They're a huge insurance company. They cater to a lot of military folks, things of that nature. Anyway, we got the call that they had 13 people on site that were sick, and they were going to the hospital, and the water purveyor had provided something within the water that was getting these folks ill. Shortly after that, their maintenance personnel had went on site and discovered that their lake that was on the property was completely dry and fish were flopping. So when we got there, we realized that they did have a backflow preventer on the irrigation, but when the pump kicked on, it pumped out of the lake back in our distribution system. So they basically pumped a little over 1 million some odd gallons worth of water that was lake water back into our distribution system. Now, point of interest is it went to that claim center first. So everybody got a cup of coffee, got a drink of water out of the water fountain, whatever. That's where people started getting sick. And in short order, they had a number of them going to the hospital. So when we got back to the backflow preventer, we realized that both check valves on an old double check valve assembly had failed. So we started chasing it through the distribution system. So kind of put your thinking hat on a little. We chased this for 5 square miles. 5 square miles. Every time we took a sample at a fire hydrant, we got a good chlorine residual. We didn't have a problem with the water. So sad as it sounds, even though when that water came back into our system totally contaminated, it was overtaken by what was in the distribution system because of the size of piping being 12, 16, and 24 inch. So it never really went anywhere except particularly at that site. So we really dodged a bullet on that one. But even today, and in today's height and awareness, or Sue happy, if you will, it would have definitely escalated way beyond that. There's a connection that a irrigator came out and he put it on the what we call the test connection. Wherever you have a meter installation, they have a test connection right after the meter. The reason why that test connection's there is if a meter is having a problem, or what they call a sick meter complaint, the guys will go out to that test connection in that box and they'll do basically what the irrigator did. They'll travel outside of the box and they'll flow that from a 2-inch gate valve that's located on it. And then that way we can determine what's going on with the meter, replace it, whatever needs to happen. Well, one of my inspectors got the call. He went out to take a look at it, and all of my guys carry a hacksaw with them. So he was out there in the process of hacking that in half when the landscape irrigator showed up. He said, "Man, what are you doing? I got $1 million something worth of grass out. We're trying to get it established. Are you crazy or what?" And he just basically asked him, "Where's your irrigation meter?" And he goes, "Oh, we haven't applied for it yet." Well, you better get to applying for it. So he, put on his panic hat, got in touch with the GC. By the following morning, they had an irrigation meter set and everybody was happy. But in that particular end, they look at it that even though it's running through a meter, it's an illegal connection, plus the fact there's no backflow prevention on it, and they were doing chemical additive on that site. So everything that they were putting into the system then, conceivably being on the discharge of the meter, he was putting irrigation right into the buildings as well, not even thinking about it. Reason why I took a picture of this is some of you may deal with the office setting, and with that, a lot of these guys will go around with these little tanks, and you can see it's got a hose bib connection off of it, right? And you think, well, no big deal. The guy's just putting his water in it. He's going to different plants within the building, and he's watering the plants. So I got over there and I looked a little tighter on this container, and if you look, they've got a note on there: water may contain fertilizers. So here this guy is, he's taking his little deal and he's going from plant to plant in the building. Then if he runs low, he re-puts whatever his plant food is, and he hooks up to another internal bib inside the building. There's no backflow prevention there until they started introducing internal vacuum breakers on these hose bibs. So if you don't have these things on your house, really think about that, because if it's operating, doing exactly what it's supposed to, you lose water pressure. If it gets into back pressure, it'll spit on your shoes. That's exactly what it's supposed to do. And in that way, you've done due diligence to try to protect your family or somebody that's in an office building. But, I tried to find the guy in the restaurant. I figured he'd have on a shirt that identified him or something, just to let him know, hey, are you making sure that you're hooking up to a protected hose bib when you go into a building? As far as temporary connections and some of the things that goes on with those, what type of connections do you have in your water distribution system? As I told you, we're like 700 square miles of infrastructure. Currently, right now, I'm manning that with 10 inspectors, and they're broke out in different sections throughout the city. The one thing that's good for San Antonio is we're very high on conservation. So with the conservation effort, it's worked extremely well to be able to protect the distribution system, because people call in. They'll say, hey, Joe's over here hooked up to a hydrant. Do you guys know about it? Hey, somebody's over here hooked up to a hose bib or a service connection. So we've got a real good networking that goes on that kind of lets us know what's happening out in the field. The other way to track it is just kind of the eyes and ears, or find it through the yellow pages. A lot of companies come in that we don't know anything about, so when the new phone books come out, I ask my guys, hit the phone books. And point of interest back to you guys, that's a good way to track your competition that's out there in the irrigation and landscape industry. You want to know who's moved into town or who's new in town? Get the yellow pages, because 9 times out of 10 they're going to have an ad in there. and it's just a good way of knowing who's who within your city. On the meeting aspect of it, I do a lot of presentations for our local group. It's known as San Antonio Irrigators Association, and I normally do 2 to 3 presentations a year for those guys. Try to keep them up to date on what's going on the city side of the house, what's happening with the water purveyor. Our conservation group, which is huge in San Antonio, I don't know what the per capita use is. Do y'all track that as far as knowing any type of use, whether it be irrigation, whether it be for potable use? But your average per person per day across the country is somewhere around 200 gallons per day. And you think, oh my gosh, I don't drink that much water, I don't take that long a shower, I don't take that much of a tub bath. But think about that. If you just sit there and calculate up in one day how much you use as a person and incorporate all that, taking a bath, using a shower, flushing a toilet, flushing a urinal, operating a sink, filling up a gallon jug that you put in the refrigerator to have cold water. Well, by the time that you calculate that all up, the average use per person per day is around 200 gallons. So it's linked back to your irrigation system, how many times that runs during the course of a week. In San Antonio, we do have ordinances in place, so you really can't water more than once a week at best. Sometimes every 2 weeks you may get to water. So we don't have these lush, beautiful lawns that a lot of them do, unless you're, I call them what do you call them? The night waterers. And that's where we have people that just sit out there in a lawn chair and they move their lawn chair around in the yard with a hose because they can't run their irrigation system. And in my neighborhood, I've got 8 of them that do that. And they've just got the most landscape. It's just beautiful year round. My wife says, how come our yard don't look like that? I said, because you haven't become a night waterer. You need to get out a good book. You need to get your chair and get out there and get after it, but I'm not going to do that. So anyway, information as far as the meetings are concerned, we have a lot of good pass-through in that. Our backflow prevention program is going to get pretty dynamic in San Antonio. We're going from monitoring somewhere around 2,000 backflow preventers per month is what we're dealing with right now on an average mail-out. It will ramp up December 1st to 4,000 mail-out per month. And it's going to go again in June 2013. We will be mailing out to about 14,000 per month as far as testing the irrigation and domestic, internal use, all that type. Of that, just landscape irrigation only, if you can imagine, we have on residential, I think we're upwards of around 147,000 folks that have irrigation systems just in and around San Antonio that we provide water to. So with that, we want to make sure that they're safe and testing their backflow preventers. Now, we do scale down where we put in a double check valve assembly versus an RP above grade. Stealing backflow prevention assemblies 2-inch and under, it's got to be a big deal. If you guys can come up with something where you can truly protect those, I mean a really bulletproof way of protecting them, there's no telling how much money you could make right now because it's a very lucrative market. They take the backflow preventer, they break it up in little bitty pieces, take it to a vendor that'll run it that's outside the city limits, and it's undetectable. It's just chunks of metal, but they're making enough money off of it that it's like $25 to $30 per backflow preventer that they're making. So they'll go out and hit these things hot and heavy. We've had numerous dentist office businesses call in with a no water complaint, and we ask them, is your backflow preventer still there? Well, don't know, let me check. Nope, it's gone. So back to square one, now they're having to deal with that extra cost. Now one thing that, if that's happening in your area that we've been told by the manufacturers it works pretty good, is paint them black. If you paint them black, they take on the appearance of anodized metal. With that, it makes it a little less, attractive to the thief, if you will, because when he puts a flashlight on it, if it don't shine, it's not worth messing with. It's one of those plastic ones or anodized. So some of the manufacturers are getting on board to that. and they're actually doing, I've seen one here, had epoxy coating that they're actually putting on the backfill preventers. It's now black 2-inch and under. So anyway, food for thought. When you get off into color coding, that's kind of a Pandora's box, if you will. As I told you before, we were talking about as exotic as, you know, yellow with black polka dots and that type of thing. Well, we try to use a little bit of separate methodology, if you will. For recycle, purple seems to be the driving force for anything that's provided by the water purveyor. On the domestic side of it, they utilize green with white lettering. That's what's predominant under your plumbing codes, UPC, IPC. The only problem is if they don't letter them and it's green, first look-see, somebody thinks that's sewer. Now, you'd think it would dictate a little bit since most of these lines are 2-inch and under. Most of your sewer lines are 4-inch and up. So little common sense ought to come to play. On the irrigation side, what we do in San Antonio is if you're providing potable water to it and you have alternative water on site, we just label it non-potable. That way it gives it a specific designation, yellow with black lettering. But again, the tapes, things of that nature is pretty expensive. Your plumbing code says it's supposed to have an overlap. We don't do that. We tell them just to attach it to the top of the pipe. The plumbing irrigation inspector seems to be good with that, and it's very cost savings in that regard. On the rain harvesting, you know, flip a coin, it's still out there. Do we make it purple? I mean, in a lot of ways, the rain harvested water is better than the potable water that we're providing, you know, if they're treating it properly. Now, if it's a first catch, then it has all kinds of contaminants in it. It's got whatever's on a person's roof. So you can have virtually anything in it. But if it goes through a first flush, then it can be as good as that system that I showed you on site, where it's better than potable water as far as its overall constituency. On the on-site reclaim, again, you know, do you want to deal with purple pipe? It's another type of water. There's no test parameters. And that's what we have a hard time, is if we provide recycled water to the site and they've got all these other waters and they blend these, there's no way to test, no way to know what you've got. So if the water ends up connected with potable water, you have no way to test it, no way of knowing what it is or where its source of origin is. The place that I told you about called Pearl, it used to be Pearl Brewery, now it's a multi-use facility. They have well water, they have reclaimed, recycled water from us, they have rainwater harvesting, they have cooling tower blowdown, they have condensate collection, and they have groundwater influence. 6 different types of water. And then they got so excited they said, hey, we want to start putting a hose bib up to all our residential sites so that they can just pull off that hose bib and water. And we're going, you're nuts. Because if you do that, you have no idea what you're supplying to these people. And I went, oh, yeah, good thought. You know, but when you get into these very complicated sites like that, they've done a great job. They've went through it. They made sure physical separation's there. We monitor it on an annual basis to make sure physical separation is maintained. But it's truly, truly a very unique site. We kind of use it as a showcase. If you want to use a water on site and see how it works, if you come to San Antonio and look me up, I will take you there. That'll be the first place we go. So please come see me. On the well water, yellow with black lettering, again, it would reflect as a non-potable, but then you're confusing it with the potable that we supply. And you've got 2 different constituencies of water. Sometimes well water even has a chlorine, a natural chlorine form in it that could be diluted enough and cause a confusion, if you will, between the water purveyor and the well water of really, what do I have here? Which one is it? The fire line, those are pretty steadfast. As you know, a fire line's designed to only operate whenever a fire happens. So fire system's constantly under pressure. So if anybody goes in and accidentally taps into a fire line, you pretty much know about it immediately, because a low pressure switch goes off goes into alarm either back to the company that's monitoring it, or you'll have a alarm go off there at the fire line riser itself. So getting into that system, not really a concern. On the fire side, of course, you worry about stagnant water issues. Other than that, not really much going on there. Color coding, you know, who is the color code police? Well, right now we kind of point at the plumber. You know, plumber is the one that's predominantly dealing with everything that you've got that's on that site, so we kind of put that monkey on the plumber's back. But the plumbing inspections folks aren't real happy about that because they're not set up out there to do water constituency testing. So if it's a multi-use site, they in turn kind of throw the monkey on our back. So if a water quality thing goes on, they call us first, we go out, figure out what's on the site, and then have a pretty good feel of where the contamination may start or where the cross connection is happening. The utility corridor, talked a little bit about that. That's where your state agency or your state rules kind of stop, and then your local jurisdiction takes over at the property line end. But if you think about it, from the meter to a building, that's really kind of no man's land, because the plumbing inspector really looks at what water uses are in the building. He's not really paying attention that much to what's outside, except for what's a little bit on the irrigation side of the house. So if you get a little exotic about the Pearl site I was telling you about, they're way out of their element. They have no idea what they're looking at. So again, it goes back to education, and we do a lot of that in San Antonio. On the plumbing codes, as far as what to address in those, a lot of them don't even really look at recycle itself. Now what we did is we amended the IPC, and if you go in and look at San Antonio's rules, you'll see where what goes on recycle or reclaim or rain harvesting is captured within their rule criteria. And I've been in discussions with some of the code authorities or national code authorities about what could they do to kind of help nationally smooth some of that over with AWWA and some of the other code officials, so we've got some continuity, if you will, across the United States. Some of the things I'd like you to kind of take away from the session that we've had here this afternoon is be cognizant that when you go in to do a job, understand what not only the state rules are, but understand what the local rules are, where you have to pull your permits, things of that nature. They may be a little bit more, stringent, if you will, of what they're requiring of you and what you'll have to supply. Also be aware that, you know, you may not be the purveying authority when it comes to landscape. Depending on the way the state rules are written, they may push back a little bit and say, hey, I know you're a landscape guy, I know what you're doing with rain harvesting or irrigation, but I need to see a mechanical engineer stamp on this, or I may need to see a licensed irrigator stamp on this. You just can't put an installer on the site. So be cognizant of the rules that they put out in front of you, and be cognizant of those ordinance, permitting, all the different things that they do. And from your side of the house, when you get involved in one of these jobs, make sure your management is aware of what they're walking into, especially if you're an estimator. If you go in there and you set your estimate up on what it's going to take to landscape or irrigate a particular site, and then all of a sudden you find out, wait a minute, the dynamics have changed because I didn't check what the current ordinance was, or permit fees, or inspection fees, or, you know, types of backflow preventers. Because there's been many cases that they've come into our locale and all of a sudden they're paying for a high dollar backflow preventer on a large landscape irrigation system, and it costs them dearly. And then because of the pressure drops, it changes all your calculations on what you had factored for your field of coverage. So the dynamics have changed on the amount of distribution pipe, or how many heads, or how many bubblers. You know, you got to be cognizant of those extra costs. Do not want to make it prohibitive to your site. Any questions? Run through it fairly quick. If you do have any questions, I do have some cards up here. I'll leave these set here for a few minutes and be here for a little bit to answer anything that you may have. Yes, sir.
Just a comment.
Yes, sir.
Maybe a thought or a suggestion. Number one, make sure you put a piece of tape over the serial number and the model number, so when the tester goes out there, they obviously can, once they paint that, pull that off, and so just crumble up.
Still be able to identify it.
Put it in the test box,
Yeah.
leaf valve, and then spray paint it with a primer flat paint. In other words, you don't want something shiny that reflects light, and then if you don't use a primer paint, it will peel off in a short period of time. But you can do that for less than a $3 can, and then obviously take the paint.
Great point. Great point.
So,
Yeah. Just a way to get them guys from, it just amazes me.
that actually, if you go to a scrap dealer and you have something that's painted, they get less money for that. And like you say, the idea is that, your meth head goes to the next shiny lure that's in the neighbor's yard or something. But in the meantime, also, they're going to learn that they get less money for a painted than a naked material.
Yeah, one lady told me in there that the one that was doing the epoxy coating, they said that when you show up at a scrap dealer, all of a sudden it drops by 80%. So instead of them getting $50 or whatever, 80% less than that is what they ended up with. There was another question? Yes, sir.
Yeah, you mentioned that reclaimed water is not good for hardwood trees.
Oh, okay. Yeah, depending on the constituent water that you have in your area, it's more towards the woody plant, anything that's a woody plant.
You're saying mainly not spraying constantly on.
You don't spray on the leaves, and especially during the daylight hours. If you get it where it's on there at night and it has time to be absorbed, but even at that, they do have a fairly high salt content, and because of that salt content, it'll lay on the leaf and not go off as a disperse. It'll just lay there, and because of that, it'll cause those leaf tip burns. But I did find one tree that it will absolutely kill dead in the doornail, and that's a pine tree. So if it hits a pine tree, doesn't matter whether it's a stalk, whatever, within a year it'll kill it deader than a hammer. But if you put a bubbler system in or a tree bubbler in, it flourishes, absolutely flourishes. But if it hits that bark or if it gets anywhere within the tree itself, man, it'll just deader than a doornail. Any other questions? All right, great. Well, thank you for your time. I appreciate it.